When you send a message, stream a video, or load a web page, your computer isn't just shouting data into the void and hoping it arrives. There's actually a whole process happening behind the scenes to make sure that information gets from point A to point B. And at the heart of this process are two protocols, TCP and UDP. They both move data across the internet, but they do it in completely different ways. Understanding the difference between them is kind of like understanding why you'd send a package with tracking versus just tossing it over your neighbor's fence and walking away. So let's break down what TCP and UDP actually are, how they work, and when you'd use one over the other. What is TCP? TCP stands for Transmission Control Protocol. Think of TCP as the responsible older sibling of internet protocols. It's careful, methodical, and makes absolutely sure everything arrives exactly as it should. When you're loading a web page, downloading a file, or checking your email, you're using TCP. Why? Because you need every single piece of data to arrive intact and in the correct order. Imagine if you tried to view a web page and half the text was missing, the images didn't load, or everything showed up backwards. That would be useless. Or picture downloading a file and only getting 80% of it. The file wouldn't work. TCP exists to prevent exactly that nightmare. Here's how TCP works. Before any data gets sent, TCP establishes a connection between two computers. This is done through something called a three-way handshake. It sounds complicated, but it's really just a polite conversation. First, your computer sends a message called a SYN, short for synchronize. Basically, it's saying, hey, I want to talk to you. Then, the receiving computer sends back a SYN-ACK, which is an acknowledgement that says, okay, I heard you and I'm ready. Finally, your computer sends back one more ACK to confirm, great, let's start. Only after this handshake does the actual data transfer begin, and that's not all. TCP also guarantees delivery. If a data packet gets lost along the way, maybe it took a wrong turn through a router, or there was some network congestion, TCP will notice and resend it. It keeps track of every packet, makes sure they all arrive, and puts them back in the correct order. It's thorough, reliable, and won't let anything slip through the cracks. What is UDP? Now, UDP is a different story. UDP stands for User Datagram Protocol, and it takes a much more laid-back approach. Where TCP is meticulous, UDP is fast and loose, UDP is connectionless. That means there's no handshake, no session setup, and no verification that the other computer is even listening. Your computer just fires off the data and moves on. It doesn't wait for confirmation, and it doesn't care if the data arrives. That's why UDP is often called the fire and forget protocol. You might be thinking, wait, why would anyone want to use something that doesn't guarantee delivery? Good question. The answer is speed, because UDP skips all the overhead of establishing connections and verifying delivery. It's significantly faster than TCP, and in some situations, speed matters more than perfection. When would you use UDP? UDP shines in scenarios where losing a tiny bit of data isn't a big deal, but delays are unacceptable. Streaming video and online gaming are perfect examples. When you're watching a live stream or a YouTube video, a few missing packets here and there won't ruin your experience. Maybe one frame gets dropped. You probably won't even notice. But if the stream had to pause every time a packet went missing, so it could be resent, your video would be constantly buffering. That would be way more annoying than a tiny glitch. Same thing with online gaming. If you're playing a fast-paced multiplayer game, you need your actions to register instantly. If your character's movement had to wait for every single packet to be confirmed and resent, the game would feel sluggish and unplayable. UDP lets the game prioritize speed, and if a packet or two gets lost, the game just moves on. Voice calls over the internet, like Zoom or Discord, also use UDP for the same reason. A tiny blip in audio is barely noticeable, but a delay in the conversation would be super awkward. The key differences. So to sum it up, TCP is reliable, ordered, and connection-oriented. It guarantees that your data arrives completely and in the right order, but it takes a bit more time because of all the checks and confirmations. UDP, on the other hand, is fast and connectionless. It sends data without waiting for confirmation, which makes it quicker, but there's no guarantee the data will arrive or that it'll be in the correct order. TCP is like sending a certified letter with tracking. You know it'll get there and you'll get confirmation when it does. UDP is like shouting something across a crowded room. It might get through, and if it does, great. If not, oh well, you'll shout again in a second anyway. Which one should you care about? Honestly, most of the time you don't have to choose. Your apps and devices handle this automatically. Your web browser uses TCP because it needs every byte of that web page. Your video streaming app uses UDP because it values smooth playback over perfection. The internet is built on both, and they each have their place. But understanding the difference gives you a much clearer picture of how data actually moves around the internet. It's not magic, it's a choice between reliability and speed, and that choice depends on what you're trying to do. Thanks for watching. If this helped clear things up, go ahead and subscribe for more breakdowns like this.